To start off this segment, I would like to invite Mr. Kester Kyong, a colleague of mine at the Maritime Decarbonization Division, to deliver a presentation on industry consultation for electric hovercraft charging and battery swap system standards. Mr. Kyong, please.
Okay, thanks, Leanne. Good afternoon, everyone. I hope you had a good lunch. So, 2 years ago, MPA kickstarted discussions with our national standards body, Enterprise Singapore, to secure resources to create national standards to support the adoption of electric hovercraft in Singapore. They lacked global standards on the charging of electric hovercraft propelled by marine batteries. By the middle of last year, we formed a working group of local experts, and 9 months later, we're ready to share the draft work with other experts to make sure we're on the right track and to learn and take inputs to improve. We do this because this is a nascent topic. It was not so easy as to simply rename Singapore's existing national standards for EV charging. I wish I could just take EV and change it to electric vessel, but the charger ratings can be in the megawatt range now, and also operations are not just near water, but actually on water, so we better get this right. The draft TR is available for public consultation, and you may register your interest to receive access to the draft and comment. Don't worry, the QR code will be displayed at the end of my presentation, or you can also visit the link in the MPA press release. Today I have a wide audience, so I'm trying to make sure that I get in touch with each and every one of you. So for those that are unfamiliar with electrical engineering, you don't know what's AC or DC, I'll just try to explain what is MPA's intent behind creating standards and how we hope to be able to regulate this better. For those of you that are quite familiar with the landscape, maybe on the EV charging side, I hope that I can share our perspective of how we thought about this from a maritime point of view and how we plan to roll out more pilot charging points. And the last group of you, you're probably a licensed electrical worker, you do all the lights in your home, you set up the solar panels, and your wallpaper is a single line diagram. I hope I can give you a glimpse on the different sections that we have for consultation to tease your mind a bit and to seek real input in our comments. So let's get on to it. My name is Kester. In MPA, my mandate is to decarbonize hovercraft. So I'm speaking to everyone today as a partner of our standards development organization at NTU, which comes under the purview of the Electrical and Electronic Standards Committee, the EESC, to support the development of this standard. This standard will safeguard electrical and mechanical safety. Interoperability between electric hovercraft is important for us, and so with charging and battery swap infrastructure going to be put in place, we need to make sure that it's shareable, and we want to ensure operational efficiency in the Port of Singapore. This is a key prong to support the development of Singapore's National Electric Hovercraft Charging Infrastructure Master Plan. Fundamental to this, we are doing master planning and spatial planning, so that's studying the optimal charging locations at public and private facilities, optimal power ratings, whether it's in the kilowatt range or the megawatt range, and we're modeling this to support marine services operations today. So we're working with the Institute of High Performance Computing, A*STAR, on this. In tandem, we also need to get our hands dirty to trial and pilot charging points for various electric hovercraft use cases. So high power DC fast charging at your destination charging, low power trickle charging at home base, onshore and offshore locations. So we recently launched our first pilot trial at Marina South Pier. So the standards will be a tool to support the development of Singapore's charging regulations and policies. The WG is co-chaired by Engineer Lim Se Leong. He's the Technical Director at Sunlight Electrical and Clean Global International. And my boss, Mr. Ng Bing Rong, who's the Director of Decarbonization Planning and Infrastructure at MPA. Engineer Lim is super experienced in this department. He was part of the EV charging system WG that prepared TR25 and the TC3 on power systems and utilization that reports to the Electrical and Electronic Standards Committee. The WG also comprises academia, class societies, industry stakeholders comprising hovercraft consortiums, charging point, technology and accessory providers, energy storage system integrators, terminal operators, and energy distribution solution providers. So I see many of you sitting in my midst. Thank you very much for all your support. The draft TR provides requirements and guidelines for fixed electrical installations to provide electrical power supply to rechargeable battery energy storage systems installed in electric hovercraft and also the conduct of battery swap operations. So this standard is based on real-world applications. It was a real-world need we needed to support the developments of the industry, and also we use these real-world operations to align with the standards. So on my left, on my right, is the direct charging at Marina South Pier. So that was actually just launched a week or two ago. And the battery swap operation was based on the use case of the hydro mover using the swappable Swift Clean Energy batteries. Sorry, can you screw up on my script a bit? Up. Yep. So it will align with relevant international electrotechnical commission standards, IEC, as well as local standards like TR25 EV charging system. It will also adopt and adapt charging practices like the Combined Charging System, CCS, and the upcoming Megawatt Charging System, MCS, which is currently being commercially developed. I know what you're thinking. With these excellent references, is there still a need for adaptation? The answer is yes. Marine operations present a unique set of challenges. Operating conditions are harsher. Anyone who has been to Marina South Pier will know that it is much, much harsher than, let's say, your average HDB or condo car park. It is outdoor and exposed to the elements. It's humid, it's corrosive. Ingress protection or IP ratings will also need to be higher. We forget that the operating medium is now at sea. Electricity and water do not mix. This impacts earthing arrangement and protection against electric shock, where the electric hovercraft is now moving along a three-dimensional plane instead of a 2D one. Correspondingly, the cable management system will also have to be a lot more flexible and complementary to the process. Now, the operating power is also a lot higher energy and higher range of voltages demanded by electric hovercraft than an EV. So I will be breaking these two sections of the standard. One section is on the direct charging and the other section is on the battery swap operation. Let's look at the direct charging one first. In drafting the section on direct charging, TR25 was extensively referred to. Singapore's electricity regulations for electrical installations require a licensed electrical worker to ensure that electrical installation complies with the Singapore Standard 638, which is the code of practice for electrical installations. This covers the flow of electricity up to the connecting point. Specific requirements of the electric hovercraft, charging system, and supply equipment with regards to safety, communication, and hardware are adopted and adapted according to specifications defined in proven standards like MCS and CCS, and also as defined in this TR. And to the right, from 2027, all new electric hovercraft must go through a compulsory consultation process on craft systems design. So any requirements for the electric hovercraft shall be determined by the implementing authority or the 8 class societies recognized by MPA. Now let's go to the battery swap operations. Just a system overview. For the section on battery swap operations, IEC 62840 was the choice reference. Similar to 62840, which is the electric vehicle battery swap standard, we identified the various systems in play and considered the various safeguards for each system. So I have 5 more minutes left and 50 pages of the standard to cover, and I'll just give you a quick snapshot. So first, I'll talk about the shore charger distribution panel. We first align to SS638, as I mentioned. We need to protect against electric shock, so we have listed a few SS and IEC standards to comply with. Insulation monitoring devices, harmonics and DC injection, dielectric withstand characteristics, and also on EMC. These are important to make sure that whatever electricity that comes into the supply equipment is safe. Then we look at contingencies. How do we have fail-safe in the maritime environment? How do we operate in hazardous areas, sometimes in areas near to bunkering, in areas near to natural gas? How do we prevent the reverse power during fault or loss of main supply, and the control circuit supply integrity? So these are some contingencies to ensure that operation is safe. Looking at the connection, we have the mechanical characteristics to make sure that it's resistant. It has to be more robust. As I said earlier, this system will be in a very xiong environment, if I may use a better word. Also, the permissible surface temperature, ingress protection of IP56, the extraction forces of less than 100 newtons, latching devices, and again, the protection against electric shock based on existing standards. I'm just giving you a quick overview, but when you refer to our standard that was made available, I'm sure this will be a lot clearer to everyone. Lastly, the one important key point is on communication. So we have aligned this to ISO 15118 and also IEC 60950. So I'm sorry that I have to speed through this, but this is a quick overview on how we think about direct charging. And again, I'll be posing some questions at the end to get your thoughts running on how we can better this standard. Moving on to the battery swap. So we divide our zones and systems into two. First, obviously, one on the sea and one on the shore. So the blue is the seaside, and the yellow and the gray is the shore side. We divide it into multiple zones. You have the mooring zone, the battery swap zone, the battery storage zone, and the battery charging zone. So all this was thought and dreamt on as we thought about how we can operationalize the hydro mover electric vessel, which is Singapore's first electric cargo vessel that will use battery swap technology. Simply, if I can guide you in the graphic from right to left, the battery will be hauled off the vessel using a crane. It'll be put onto like a prime mover, moved to the battery storage zone, charged at the battery charging zone, moved back, and the process repeats. Like always, if there's something we can refer to, we take the opportunity to do so. So on mooring, we make sure that we follow IMO guidelines on safe mooring to ensure that during the battery swap operation, the vessel does not drift away and cause the battery to fall into the water. There's also MOM regulations on WSHC to ensure that the crane operations are done safely, the lifting operations are done safely. And also AC/DC charging off-site on land, whether it's using IEC 61851, CCS, MCS, or even TR25. Lastly, we try to protect against, mitigate individual pain points in each system to ensure that the whole operation is safe. So whether it's on hard landings and unsafe releases, arc flashing and short circuits, lightning, penetration and puncture, we make sure that we have given enough operational guidelines in the standard to ensure that the operation is smooth and without a hitch. Today, we look to you, our international and industry experts, to refine and charge up the draft. Some questions to get you to help us to think about this. Is the voltage cover in the scope sufficient in range? We tried to refer a bit to TR25 and IEC standard voltages, but we need your input on whether this is sufficient for the maritime industry. Is there a need to further marinize key equipment? Are there any pertinent safety concerns that we might have missed out? And are there any charging methodologies or systems that we should also consider? I've come to the end of my presentation. The public consultation will be open for 2 months. You may submit your comments accordingly to the template provided in the last few pages in the draft, and all comments received will be collated and deliberated upon by the WG. Please let me know if you have any questions. I'll be happy to take them over coffee or drink. And again, we welcome all expert contribution. Thank you very much.
Thank you, Mr. Keong, for kickstarting our last segment with very insightful information. Let's give Mr. Keong another round of applause as he makes his way back to his seat.